Okay, today, as usual, we want to talk about algebraic identities for this session, but I want to start with a new problem, okay? And I want you to hear your opinion about it. And please try to speak very loudly because it would be better if they are going to watch the movie, the video, they can hear you. Okay, so my question for you is this. If I give you this, I tell you that x and y are real numbers, and then you have x minus 1 to the 2 plus 2y minus 4 to the 2 is 0, and I ask you to calculate x squared plus y squared. Okay? So I give you this equality, and I'm asking you to calculate x squared plus y squared. Okay? I want to hear how do you think about the problem? First of all, I want to see that, is it a little bit surprising or not? You should be surprised a little bit. I don't know how to say it. You will understand what I mean. But it should be a little bit surprising. Why? If I give you this and I ask you this, are you surprised a little bit or not?
Confused, mostly.
No. Okay, say something, Lube. What do you want to say? I want to hear you.
No, it's not like any patterns you give us.
No, more general things like patterns. Why you should in principle expect this is an odd problem. This is a little bit a strange problem, yes?
It's a brand new strategy.
No, that's not what I mean. I know my question is completely vague, but let me see how you think. Yes, Emilia?
You have two variables, but you only have like one equation.
Exactly. So this is the core, yes? This should be surprising for you. How many pieces of information you see on the board? One. How many variables are involved? Two. It's a strange problem. I'm asking you to solve something with two variables, but I have provided you apparently only one piece of information. This should be surprising for you. These kind of things I really want you to learn in mathematics, yes? Do you understand what's going on? I am asking you x squared plus y squared. It is involved with two variables, but I have only applied one piece of information, apparently. For example, if you recall what we learned last time, I asked you, do you remember that was the problem? I gave you x plus y is equal to xy is equal to minus 2. And then I asked you to calculate x squared plus y squared. Do you remember? But how many pieces of information did I provide for you last time? 2 pieces. Okay, so that is not surprising. It might be a little bit difficult. That is the strategy that Alex was talking about. I told you what would be the strategy. But this is not the strategy. This is a little bit strange from the beginning. Here, I provided you 2 pieces of information, and I asked to calculate this, which involves 2 variables. Yes?
Is it possible to
Louder, please.
Is it possible to rethink x squared plus y squared as one variable and then substitute that into the
Okay, but no, it doesn't work. That's the problem. I want you to understand. The number of pieces of information that I've provided for you is just 1, apparently. But there are more information hidden here. I want to talk about that. So my goal is that in principle it should be a little bit surprising for you. I have provided for you 1 piece of information, and I somehow expect you to answer a question mark involving 2 unknowns. In principle, this is not, something is wrong going there, unless there is an extra piece of information hidden in this one single equation that you need to be smart enough to extract that information. This sentence is very important to understand. Do you understand what's going on? Is that understandable for everyone? Yes? Okay. So I want you to see that I am not talking about the details. I am talking about the grand strategy. The strategy tackling this problem is probably different from tackling this problem. Yes? Okay. But there is an extra piece of information hidden this. So you can answer this because even though I have written one equation, and I have given you one piece of information, but there is another piece of information hidden in this. I want to talk about that. Okay? So let me ask you some question. If I give you a plus b, a and b are numbers, and I say that I have chosen two numbers in my head you are not aware of. One of them is a, one of them is b. And I give you this piece of information. A plus b is 0. Can you immediately conclude something about my numbers for sure? Certainly, yes?
They are opposite or equal to 0.
Okay, so but it means that you cannot specify exactly the numbers in my head. Yes? You can say that there are many choices that you can have chosen. Yes? You might have chosen a to be 1, b to be minus 1. You could have chosen a to be 2, b to be minus 2. I don't know. So just using this piece of information, I am not able to give you the exact values for a and b. Yes, Lube? Louder.
A equals minus b.
This is the most that you can say, but you cannot specify my numbers. Yes, but let me provide you another piece of information. I guarantee you that my numbers are non-negative. I guarantee you the numbers that I have chosen in my head are non-negative numbers. Then can you specify a and b? Yes,
They're equal to 0.
they have to be equal to 0. Do you agree? So if I just give you a plus b equal to 0 and I ask you what the numbers a and b are, you will not be able to answer them. There are infinitely many possibilities. Yes? Agree with me? But now I guarantee you that the numbers that I have in my head are non-negative. This piece of information together with this piece of information is enough to conclude that what? A is equal to b is equal to 0 if I give you this extra piece of information. Agree? Do you agree with me or not? But that piece of information is hidden in this equation. Do you see that? I didn't mention it by words, but if you know a little bit of mathematics, you realize that this expression is non-negative. Why? Even though I don't know x, I don't care about this, anything to power 2 is non-negative. So this is non-negative. Hidden, you see, this is more than one piece of information. This is non-negative. What happens about this? This is also non-negative. And then I have something which is non-negative added to another thing which is also non-negative, and the answer is supposed to be 0. There is only one possibility for that. What is that possibility? Both of them are equal to 0. Yeah, so this is very important. I want to talk a little bit about that before going to the next one, to the next topic. So let me write it from here. So I would write, if I want to solve this problem, 2y minus 4 to the 2 is equal to 0. So I would say that since x minus 1 to the power of 2 and 2 minus y minus 2y minus 4 to the 2 are always non-negative, and the sum is 0, we conclude that x minus 1 to the power of 2 is 0, and 2y minus, let me write this word and, it's crucial to write it, so let me write. And the other one, 2y minus 4 to the 2 is also 0. Okay, but do you think then how many equations are involved now? 2 equations. How many unknowns do I have? 2. So that piece of information was hidden. So again, you see that I was not able to answer this certainly just using one piece of information. The other piece of information was implicit into this equation itself. So again, using that piece of information, I was able to write two equations. And how many unknowns do I have? Two unknowns, two equations. So in principle, I should be able to solve it, yes? So what is the value for x? X is 1. What is the value for y? Y is 2. But what was the question mark? The question mark was x squared plus y squared. But I got x is equal to 1, and then I got y 2, so the answer is 5. Is that understandable?
Yes.
Okay. So there are three famous things in mathematics whose output is non-negative. One of them I just told you, yes? Even powers. The output of any even power of any real number is non-negative, yes? Can you see another? There are two more more famous ones. The output is non-negative.
Square root.
A square root, not only square roots, any even root, yes? So that's right. So let me clean this here. Okay, so famous non-negative expressions. Yes? So one of them, even powers. 2, 4, 6, etc., etc. Even roots. The second one, even roots. As you said, a square root is one of them. And there is one more famous one. Probably you are not very, yes? Emilia?
Absolute value.
Exactly, very good. So the other one, absolute value. So these are famous expressions in mathematics whose output is non-negative. Yes. So for example, if I have x to power 6, it's non-negative. If I have z to power, for example, 8, it's non-negative. So even powers are non-negative. Even roots, for example, the second root, because whenever we don't write something here, that is a second root. So this one is non-negative. For example, the 6th root of y is also non-negative. Here, the absolute value of anything that you see is non-negative. The absolute value, for example, of z minus 2, this is also non-negative. Whatever you like, yes? The output. Is that clear? So remember these three things in mathematics. But there is an exception here. Here, when I am dealing with even roots, not only the output is non-negative, I need to be careful about the inputs. I cannot put negative inputs. But I don't have these restrictions here, here, and there, yes? I can put a negative value for x, but the output becomes non-negative. I can put a negative value for z, the output becomes non-negative. I can put a negative value for x, the output is non-negative. But here I cannot put a negative number for x. I have to put positive numbers there, and of course, if I respect that, the output is non-negative. Is that clear? Okay. Now let me give you some examples and try to solve them together. Okay. Example. Let x, y, and z be real numbers such that we have this relation. The fourth root of 2x minus 6 plus 3 absolute value of 2y minus 8 plus 9 minus 3z to the 4 no, to the 6 equals to 0. Let x, y, and z be real numbers with that property. Calculate x plus y plus z. Okay, so I have combined all these three expressions, famous ones, in one problem, but that I don't count it as a very nice problem. I will give you nice problems right now. So now you realize that before starting up today's lesson, this was surprising, yes? Because you think that I have given you one piece of information, but I have involved with three variables. But that is not one piece of information. Other pieces of information are hidden here, yes? Because I know that this expression, can this expression be negative?
No.
No, because it is an even root. Can this expression be negative?
No.
No, because it's absolute value. Can the last expression be negative?
No.
No, because that's even power, yes? The sum of three non-negative numbers is supposed to be 0. There is only one way that this can happen, only if each one of them individually is 0. And then the problem is solved, yes? Because therefore, I would write that this one is 0, but you immediately can see what is x to make this one equal to 0? 3. So x is 3. The next one is supposed to be 0?
4.
Yes, exactly. Because absolute value of 0 is 0. So y is 4. And then what is the last one? 9 minus 3z to the 6 is equal to 0. When this happens, yeah, z is 3. But what is the question mark? The question mark is x plus y plus c. But what is x 3? What is y 4? What is z 3? So it's 10. Yes? Is that understandable?
Yeah.
Okay. Now I want to give you a little bit nicer problems. Let us see how you will respond to this. Now that you understand the strategy, now we want to solve a little bit harder problems using the same strategy. Example. Find x, y, and z. So I will give you two examples. I will wait for it. So number one, x squared plus y squared plus z squared minus 4x plus 6y minus 8z plus 29 is equal to 0. Usually in the contest problems, they use some kind of this, yes? You need to review. You need to change your point of view to be able to solve this problem. This is a little bit strange, yes? I have given you one piece of information. It contains negative signs, but I am asking you to solve three unknowns, okay? You know everything at your disposal. Then you need to be a little bit smart to be able to solve the problem, okay? Smart and experienced. In this classroom, we are gaining experience, but that is up to you to solve problems, to become smarter, yes? So please try to think how you can solve x and y and z. And I will write you a little bit harder one. Hopefully I have written everything right. Yeah, okay. Yeah, it's very good if you have some opinions, talk to me, and please talk louder so that I can have your voice in the video. Shout like me, yes? On the lessons here, because we have a little bit short time, I cannot stay a long time. This is why I want to hear from you. What do you think I should do? I cannot wait more than that. I don't want you to finish the problem, but do you have any general idea what to do? Yes?
Create even powers.
What do you mean? Can you elaborate more?
Well, for instance, on the first,
Louder, please.
on the first one, you can take x plus or x minus 2 squared and y plus 3
Yeah,
squared.
the strategy is
and,
completely right. Yeah,
and
that is
step
the strategy. Thank you very much. So he is telling that try, because you know the quadratic pattern we talked about last time. Yes, he is telling that try to create 3 quadratic patterns out of it. Why this quadratic pattern is a good idea? Because you know that the quadratic pattern has an even power too. And if I combine that idea with this new idea, the problem might be solved. Yes, that's a very good thing. Yeah, thank you very much. So let us do that. But the rest of it is details. Yeah. So for example, how should I? He said that okay, I can take this one, x squared, with that one. He's completing the square somehow. Okay. So I write x squared minus 4x. But this is not still a complete square. Yes, I need some number here to make it complete a square. Okay. Let us forget about that for the time being. This is the way that you need to think to learn mathematics. And then I have y squared. Which one do you prefer to write next to y squared? 6y, yes? So let me write 6y here. But it's still not complete. I need something here. And then what is left is z squared and then minus 8z, yes? And then I have equal to z. What do you think I need here to make it complete the square? I need 4, yes? So I put 4 here. But remember, how much I have? I have 29. So that is the responsibility of the person who designed the problem to give you the correct number, yes? I need 4 of it here. How much I need here to make it complete the square? 9. I need 9. So far, how much I have used? 13. What is left? 16. So I have to put 16 here. But is 16 the correct number that I need? Yes. So this person who has designed this question have already thought about this. Yes? And then let us do that. What is this one now? This is x minus 2 to the 2 plus y plus 3 to the 2 and then plus z minus 4 to the 2 equals to 0. Agree with me? And then you immediately combine this by the previous idea and you can immediately solve the problem. So this means that this is non-negative, even power, non-negative, even power, non-negative, even power. Yes? So this implies that x minus 2 to the 2 is 0 and y plus 3 to the 2 is 0 and z minus 4 to the 2 is 0. And then you can find x is 2, y is minus 3, and z is 4. So we found the problem. It's amazing, yes? Because you have only one equation, 3 unknowns, and you were able to you exactly find the answers. These are unique, no other solutions, yes? Yes, so the other information was hidden in this problem. You were able to extract that hidden information. Let me make it a little bit harder. This is a little bit harder, but now you have a lot of experience. So you can probably solve this one. I want to give you a little bit of time. If you want to study time, my study time starts at 12:30. Okay. Yeah, this is inspiration. So can I raise that? Yes, because yeah, you can watch the movie later. It's movie is not a good word, yes. The video. You can watch the show later. That's by the way a show if you like it. This is a little bit more tricky. But the idea, I believe that all of you know the idea. You are struggling with making the correct pattern. Now you have some experience. Talk to me, because this is important. I want to see how do you think about the problem. So if possible, I can correct you. Do you want to say something, Emilia? You did great today, actually. Jonathan, your idea was very good in the first one. So this is the problem. This is the nature of mathematics. You know everything right now. You are dealing with the trick. You need to find the trick. You don't need more math knowledge here. You have everything. Say something, say something.
Maybe the question becomes easier if we factorize.
Yeah, the idea is to complete the squares, again, like that. But I made it a little bit harder. I don't want you to use to trial and error all the time. You need to have a strategy. Of course, trial and error is inevitable sometimes, but not. So you need to have a wise decision from the beginning. So do you agree with me? The idea seems similar to that. At least, do you feel it? Okay. So if you feel it, you need to try to do something. I have x squared. The bad point here is that I have a mixed term x and y. But this is not an obstacle. Tell me, how can you circumvent this? No, this doesn't work. Yes, Lube? You want to say something? If yes, louder.
Maybe 2z squared.
No, it doesn't work that way. Sima, did you want to say something?
X minus z to the power.
Why x? By the way, let us. Why do you think x minus z to the power of 2 will not work? Why? This is not hard to see. Why x minus z to the power of 2 will not work? So you need to ignore that. Yes, please.
Why?
You don't have any terms involving both
X and z. You see, this is not hard. This is mathematics. I want you to learn these small tricks. So the proposal of Sima will not work. I don't need to go further. Why? Because x minus z, you said something. It means that I need to have 2 times xz. But now I don't have 2 times x times z, but I have extra thing. Now you can complete it, I think, yourself. You don't have the mixture of x and z. You have a mixture of x and y. So the Sima's ideas was correct more or less, but it was the wrong variable. Is that understandable? Okay, now we don't have more than this time, so let me finish it. I would say that I have x squared here. I have minus 4xy here. Please make it complete square. What do I need? I write x squared minus 4xy. I put some empty space here. Yes? What do I need here to make it complete square?
And 4y.
4y squared. Do I have enough y squares?
Yes.
I have 5 of them. 4 of them I will borrow for this. Yes? I'm not saying that this will work, but this is better than doing nothing. Okay, but you need to keep good track. How many y squareds are left so far for me? 1. So this is not any more there. I have only 1 y squared left. Yes? Okay. And then this is totally gone. This is also totally gone. I am just crossing them over not to confuse myself. Okay, I hope that you can finish it. Now you know the idea. Come on. Yes, Lube?
Y squared.
Louder.
Y squared minus 2yz plus z squared.
Yes, do you agree? This is also a completed square. Do I have enough? How many y squared are left now? Nothing. I had only 1 of them. I use this here. Yes? How many z squares are left? 1. 2z squared were there, but I have used 1 of them. 1z squared is left. Minus 2yz squared is also gone. What is left, by the way? Z squared minus 2z plus 1. This is the most famous quadratic pattern, isn't it? So then it becomes plus z squared minus 2z plus 1 equals to 0. So you see, it was not hard. But now you have a lot of experience. You need to do the exercises for this week. I will give you a lot of these kind of questions. Okay, then everything becomes clear. Take your time. Do you agree with me what I have written here is correct? Yes? Do you believe in that? This 1 to power 2 is exactly this one to power 2 is exactly that one. And then I can use the same idea once more. But of course it is a little bit tricky than before. This is non-negative. This is non-negative. This is also non-negative. Why? Because I have even powers. So then this implies that x minus 2y to the 2 is 0, and y minus z to the 2 is 0, and z minus 1 to the 2 is also 0. Yes? But what can I conclude? Can I find x and y here? No, I can find a relation between them, yes? I can say that x is equal to 2y. Here, I can say that y is equal to z, and finally, this will help me to solve the problem. Yes, this tells me that z is equal to 1. When z is 1, I put it back here. I find y equal to 1. And when I find y, I put it back here. I can find my x. What is x? 2. So this is a very interesting problem, yes? So now you have some experience. I will give you some of these exercises. If you do not do the exercises, of course, it is not useless, but it's not that useful. You need to do it yourself. Is that understandable? Yes or no?
Yes.
Okay, I want to switch gears to a theorem which is related to this. Okay? That's a very important theorem, especially if you want to do some contest mathematics, national one or international one. These things you need to know very well. So I would call it theorem. Let me see my notes. Yes, I can write this one now. So theorem. Let A, B, and C be real numbers. And then A squared plus B squared plus C squared is equal to AB plus BC plus CA. These kind of expressions in algebra are ubiquitous. So it is, yeah, you are getting used to these kind of expressions little by little. Then this is equal to that if and only if. By the way, IFF is not a misprint. In math books, it means if and only if. if and only if A is equal to B is equal to C. So you need to remember this theorem if you want to be able to solve harder problems. So this is a very interesting thing, you see. If I have this kind of expression, a squared plus b squared plus c squared becomes equal to ab plus bc plus ca, then this happens only and only if all of them are equal. This cannot happen otherwise. Okay. After a theorem, in principle, you should have the proof. Yes, but sometimes the proof are higher than the level of the lesson. I will ignore them, but not this one. We have to prove it. Okay, first I want to tell you something about if and only if phrases in mathematics. When a theorem is expressed by if and only if, this is not one theorem, this is two theorems. You need to assume this is true, prove that this is happening, and do the other way around. Assume that this is true, prove that this happens. When you say if and only if, this is the meaning. This is one expression, but if you want to prove it, you need to prove it in two directions. Okay? So if I want to write it like that, so let me, before writing the proof, this is the meaning. A is equal to B is equal to C. If and only, it means that if this is the case, I can conclude that a squared plus b squared plus c squared is ab plus bc plus ca. On the other hand, if this is true, then I can conclude that a is equal to b is equal to c. I have to prove both of them. This is the meaning of if and only if. Once you assume that this is true, you prove that this is also true. Another time you assume that this is true, you prove that this is also true. And usually one of them is simpler than the other one. So let me write 1, 2. First of all, do you understand what I said just right now? The word if and only if? Yes. I want to prove the first one for you. The first one is very easy. Okay. Can you just give me the idea? This is I know. For the first part, I assume A is equal to B is equal to C. I want to prove that A squared plus B squared plus C squared is equal to this expression. Yes, Alex? Today?
In the first term, you substitute B by A, and then in the second, you substitute C by B.
And compare them.
Yeah.
Exactly. That's good. So I would say the left-hand side is equal to. If A is equal to B is equal to C, on the left-hand side, which is A squared plus A squared plus A squared plus B squared plus C squared, I can replace B with A. I can replace C with A as well, because all of them are equal. So it becomes A squared plus A squared plus A squared, which becomes 3A squared. Agree? And then I calculate the right-hand side also. The right-hand side is AB plus BC plus CA. Am I allowed to write A instead of B here? Yes, because I'm assuming that they are equal. So this becomes A dot A. The next one, I am allowed to replace B with A, C with A as well. So it becomes A dot A. And the next one is A dot A. So do you agree this is A squared again, A squared, which is 3A squared. So if I give this one number 1, this number 2, if I compare number 1 and number 2, what can I conclude? I can conclude the left-hand side is equal to the right-hand side. So it was so simple, and it is more or less trivial. But the other one is interesting. If you, for some reason, see this equality happens, then you can immediately conclude that A and B and C has to be the same number. Have to be the same number. It is not possible. Okay, can you prove that one for me? Or give me some hint. Okay, so let me write it for you here. So number 2 now.
Move them to the other side.
Yes, that's a good idea. Let us do that. A squared plus B squared plus C squared is equal to AB plus BC plus CA. Okay? You propose to move them to the left-hand side. Okay, I will do whatever you said. So then it becomes minus AB minus BC minus CA equals to 0.
Then we use the strategy from the previous questions.
Okay, but how? Yes,
By
you are right. We want to use the previous strategy once more here again.
creating squares.
Okay, how?
We
Then what is the obstacle here for creating a squares? See that point. Yes, Lube, louder.
We have
Now, what is the obstacle? You need to see the obstacle. Yes, Martin?
It's minus.
No, minus is not an obstacle because we have minus sign in between sometimes. Yes?
We don't have single values, for example, 1 to the right.
No, that's not an obstacle. Yes?
We have no constant.
No, that's not an obstacle. Yes?
well, they won't complete to complete squares in its current form.
I need what that I don't have for completing a squares?
the third value.
What?
The third value.
What do you mean by third value?
Well, we have the a squared, and then we have the plus 2ab, and then we have the plus c, and we don't have the c part.
Okay. So then how should I circumvent that? So the obstacle that I see is 2. Because in quadratic pattern, I have 2 times the first one times the second one sometimes. But the cross terms are missing the 2. Yes? Do you have any suggestion, Lube?
You can multiply everything by 2.
By 2. So you see, you need to be observant. You need to train your eyes for some patterns. A quadratic pattern always tells you 2 times the first one times the second one, yes? But 2 is missing from here. Okay, what can I do? 2 is missing, I need 2. What is the most natural thing? Multiply by 2. It might doesn't work, I don't know. But at least it is better than doing nothing. Yes? So I multiply everything by 2. Do you agree that I can do that? If this is supposed to be 0, I can multiply both sides by 2. The relation is still valid. So it becomes 2a squared plus 2b squared plus 2c squared minus 2ab. Okay, so I multiplied by 2. Now I think you find the pattern. Yes, Lube, you want to complete it yourself?
Yes, a squared minus 2ab plus b squared.
Okay, so let us wait. Yeah, I understand. You understood what's good. So you see how many a's I have? I have 2a squared. One of them I used here. One of these b squared I used here. And then for the next one, I can write a squared minus 2ca, for example, plus c squared. Yes? You see, a squared and a squared, I used both of them. So no 2a squared is left. Minus 2ab, I used it. Minus 2ca, I used it. I used 1c squared here. So how many c squared are left? 1c squared is left. I used 1b squared. How many b squared is left? 1b squared. And then I can combine the leftovers to another brackets. B squared minus 2bc and plus c squared. Do you agree with me? So this is why I don't, because if I just tell you multiply by 2, of course you understand it. The point is that later you should be independent of me. Yes? You should be able to understand these things yourself. And it is doable, it's not that hard, yes? I was trying to make the pattern. In the pattern I need 2 times the first one times the second one. I am missing 2 everywhere. So it motivates me, let us multiply by 2. I don't know it will work or not. But in this case, it worked. Yes? Can you conclude? Can you finish everything now yourself? Do you believe that you can do this? Yes or no?
Yes.
Yes, okay. So how can we finish it? This I can collect it back, a minus b to the 2 plus what? A minus c to the 2 plus b minus c to the 2. And for the same reason, so non-negative, non-negative, non-negative. So the sum of 3 non-negative numbers is 0, so there is only one possibility for this. The first one is 0, and the second one is 0, and the third one is 0. Yes? So from here, what can I conclude? A has to be equal to B. From here, I can conclude A has to be equal to C, and from here, And what is the conjunction here? It's always and. A is equal to B, A is also equal to C, B is also equal to C. What does this mean? All of them are equal. Yes? Understandable? Okay, so let me give you an example. I will write the examples, wait for you a little bit, okay? So example, as soon as you see the first example, you will start solving it. Let x, y, and z be non-zero real numbers such that x squared plus y squared plus z squared is xy plus yz plus zx. Find the exact value of this expression. The expression is x plus y plus z to the 3 divided by 3xyz. Okay, so you start thinking about this problem and I will write one more for you. So where should I write it down? I can write it here. Solve the following system. Okay, I don't have enough space, so I will write it here.
This is
12:35. Because I want to solve those problems before leaving, can you just guide me what to do with the first example?
And then other side.
Yes, you didn't say anything today.
We can prove that x equals y equals c. Then we can give the number in the x.
Exactly, but you don't need to prove it. We use the theorem. Yes? So I am yeah, exactly. But the only thing is that, can you see that this is exactly the same pattern, but I played a little bit of trick. Instead of A, B, and C, I wrote X and Y and Z. But it doesn't matter, yes? This is the same pattern. The sum of squares is equal to xy plus yz plus zx. According to the previous theorem, what can I conclude? So, x squared plus y squared, of course, if you prove the theorem in the exam, it is not wrong, but I'm telling you that you really don't need to do everything from scratch. That is the whole point of having theorems. Yes? But you are completely right. Okay, so this is why. Can you see that I can conclude that based on the theorem, I can conclude that x is equal to y is equal to z. Is that understandable for everyone? But what is my question mark? My question mark is to find this value. This is, by the way, horrible. If you don't want to use this effectively, raising this to power 3, how many terms will be involved? 27. Yes, you need to multiply this by itself 3 times. So it would be 27 terms involved. But you don't need to do that. The question mark is equal to x plus y plus z to the 3 divided by 3x, y, and z. But now I realize that all these variables have the same value. Which value, I don't know, but I know that they are equal. Yes? So what can I write? I can write x plus x to the 3 divided by 3x times x times x. Agree with me? Okay, the denominator is completely clear. What is the denominator? 3x to the 3. But what is the numerator? X plus x has a better name. It is 3x. And then to the 3. Yes? X plus x. But this is much simpler. This is hard. If I want to calculate this, I need to write it. It becomes 27 terms. But now this is super simple. This is a product. I want to raise it to power 3. I know the rules from powers. So what happens? It becomes 3 to the power of 3 times x to the power of 3. And then I have divided by 3 x to the 3. Yes? And the point is that I don't need to know x, because x cubed and x cubed are cancelled. Okay? And then I am left with 27 in the numerator, 3 in the denominator, which is 9. So do you understand how I use the theorem? Okay? It's very effective. Okay? And now let us go to this horrible system. First of all, you need to feel bad. Why? When you see the system, I don't know how to say it, but you need to feel bad when I give you this system. Why? Again.
It's long and small.
Okay, that is not very bad for me. The bad point is another thing. It's against my intuition. I just opened the lecture today by that sentence. Why this is a little bit non-standard problem? Yes?
Because the information doesn't... Oh, because...
It seems doesn't fit the number of unknowns, yes? How many unknowns do I have? 3. How many pieces of information I have? 2. Whenever this happens in mathematics, you should be a little bit scared, because this means that the problem is a non-standard problem. Yes? Do you understand what I mean? Okay. So it means that if you want to use the normal tricks, it doesn't work. Don't go for it. Don't multiply, square, things like that, waste of time. It's not a standard problem, so the standard methods will not work. Probably. Yes? But now, can you tell me how it works? I want you to broaden your point of view. Can you detect this long pattern? Yes, this time. This is the same pattern. Yes? I have played around with it. Yes? So this is the same pattern, but x is x. Instead of y, I have written y minus 1. Instead of z, I have written z minus 1, minus 2. Yes? But then I have also respected on the right-hand side. X times y becomes x times y minus 1. The next one, y times y, is exactly this one, and that is the exact. Can you recognize that this is exactly the same pattern? If you can, you can save my energy. Yes or no?
Yes.
Okay. So what is the conclusion? So what can I conclude here based on theorem?
X equals y minus 1 equals z minus 2.
Do you agree? So yeah, this is much simpler, yes? This is a non-standard problem, but if you realize the trick, this is much simpler than the normal problem. Yes, because I immediately got this information. And how many pieces of information do you see right now? This is 3, not 4. Yes? There are 3 pieces of information. 1 equation, 2 equations, and 3 equations. How many unknowns do I have? I have 3 pieces of information, enough. So I reduce the non-standard problem to a standard problem, and I hopefully know how to solve it. Okay? So how should I solve this? I would write this system, and I will solve the problem. So let me write it here for you. So then I can write my system like this. X is equal to y minus 1 is equal to z minus 2. And then I have x plus y plus z equals to 6 from the beginning. Okay? I want to wait for you for 1 minute. I want you to give me the answer. This is a highly simple question. Do you have the answer?
Yeah.
Yeah, what's the answer?
X equals 2, y equals 3, z equals 4.
Okay, how did you find that?
We put, so first we can put x plus x equals 6, so 3x equals 6, and then we set in the equation we can put y minus 1 plus
Exactly. So that's called substitution method. I have 3 variables. You have seen it in Math 2C. You use substitution method to be able to solve the problem. So here, I write everything in terms of 1 variable. In Math 2C, we learned it yesterday, yes? We have 3 unknowns. We have 3 equations, 1, 2, 3, yes? So what should I do? From here, I find that y is equal to x plus 1. Do you agree with me? If you see here and here, I move 1 to the right-hand side, y becomes x plus 1. Now, what can I write for z in terms of x? Look here and here. What is z in terms of x? X plus 2. Do you agree with me? And then I can substitute y here and z here. What happens? I have x plus, instead of y, I have x plus 1. Instead of z, I have x plus 2 equals to 6. But x plus x plus x is 3x. 1 plus 2 is 3 is equal to 6. I move 3 to the right-hand side, it becomes 3. I divide by 3, x becomes 1. When x becomes 1, I put it here. Z becomes 3. I put it here. It becomes 2. So the answer to this is 1, 2, and 3. Okay? So you see that you need to read the patterns. Okay? If you don't have this pattern in your mind, in your head, probably solving this problem is hard. So it means that you need to discover the proof of that theorem yourself in this problem and then use it. I'm not saying this is not doable, but it means that you are doing everything from scratch once more. But try to learn these tricks, yes, if you want to solve harder problems. Okay, so I think that is finished. Everything about the quadratic pattern more or less is finished. Then I will switch to the next identity next time, okay? And I will try to design questions considering these ideas, and I will publish it by late tonight, okay? And then I will publish the video probably immediately after checking it's working or not, okay? No questions? Okay, thank you very much.